Ask questions. That's what I'm here for. So we're okay with inverse? Are we sure? So no questions. None. So you're saying I can move on? Going once? Going twice? All right. Then let's get to partial fractions. Decomposition. So when we look at fractions, we have proper fractions and we have improper fractions, right? What are improper fractions? What are improper fractions? Because in fraction we have mixed fractions, right? That's whole number with a fraction. So it's mixed, right? What's an improper fraction?
A fraction where the numerator is larger than the denominator.
The numerator is larger than the denominator. Yep. So like 4/3, right? However, in this case, we're not looking at numbers, right? We're not looking at 4/3. We're looking at the largest powered term on top versus the largest powered term on the bottom. Just like if we were looking at horizontal asymptotes. Okay? So with that being said, an improper fraction is now going to be something like this. That would be now improper, where the power on top is larger than the power on the bottom. Where proper would be something like this. Right? Where the power on top is going to be less than the power on the bottom. And improper is when the power on top is greater than or equal to the power on the bottom. Now, when we have a proper fraction, we're going to go ahead and just factor the bottom. With the improper, we're going to go ahead and use long division. To create a mixed fraction. Then what we're going to do is we're going to take the partial fraction decomposition on the remainder. Because after the long division, once we have a mixed fraction, the fraction is now going to be a proper fraction. Right? Well, that means now we're going to have to, again, factor the bottom. And for both of these, you may need long division. Again, so again, this is something new. It's going to be intimidating in the beginning, but it really isn't that bad. So how do we set up a partial fraction decomposition? This is all going to be based on the denominator. So if the denominator was ax plus b, that's a linear, is that right? What's smaller than a linear? Okay. Let's say we'd look at quadratic. So let's say the denominator is a quadratic. What's smaller than a quadratic? So as I was writing that, I was like, I wonder if in their mind they're asking the question, what do you mean by smaller? Is that the right question? Is that the question you're asking? What does it mean by smaller? So remember we said that a proper fraction is where the power on top is smaller than the power on the bottom. Yes? So if you look at the quadratic, what's the highest power term? The ax squared. What is smaller than an ax squared? It'd be an x, right, to the first power. Because again, the numerator is not related necessarily to the denominator. Okay? So since the highest power term is a power of 2 on the denominator, I want the numerator to be 1 power less. So if I have x squared, then what's smaller is x. What equation do we know that is going to have an x? A linear. So that's going to be ax plus b. So let's go back to the linear. If the denominator is ax plus b, what's smaller? Just an integer, right? Because it'd be x to the 0 power. Make sense? So we're going to call that a. We always start off with a on the top, okay? No matter what the bottom is going, the a is always going to be, the top is always going to start with a. Now, are we ever going to see others? So if you notice that on the linear line, we have linear and then repeated linear. We have quadratic and then we have repeated quadratic. And like, what does that even mean? Okay? So the difference between linear and a repeated linear is if we have a linear that's being raised to a multiple power. So like 3x plus 2 quantity squared. That's repeated because it's 3x plus 2 times 3x plus 2. I think I said 3x plus 2 squared, right? I don't remember either. So if it was 3x plus 2 squared, that's actually repeated because 3x plus 2 times 3x plus 2 is now repeated. Does that make sense? Okay? That's what it means by repeated. So if I had that, so let's say, for example, I'll put down here what repeated linear means. So let's say I have ax plus b squared. Then a repeated linear would have to be the a, because a is smaller than the ax plus b. Then I have to add to it b times ax plus b squared. Now, if this was a 3 to the third power, then we'll have to add another one. Yes?
And then if there was a d, would it need to be a plus b to the fourth?
Correct. So in other words, let's do it this way. Let's say that this was an unknown power, let's call it p. Okay? Then what I would want to do is, I would say that this is going to be dot, 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 plus, I guess I would call it p, to the ax plus b raised to the p power. Right? So however many that power is, I got to write it so many times. From its first power all the way to the last power. So if it's to the fifth power, then I got to write the a to the first power, b to the second power, c to the third power, d for the fourth power, e to the fifth power. Okay? So that's what repeated means. Repeated quadratic means exactly the same thing. So if I had, oh boy, ax squared plus bx plus c to the p, I would have to write, oh boy, this is going to be ugly, ax plus b, oops, bless you, over ax squared plus bx plus c plus cx plus d over the same thing, but squared plus dot, 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 plus, oh boy, I don't even know what the letter is going to end up being, but we'll just make up some letters. Let's say px plus r over Now notice that every single time I write this, on all four of these, that I'm writing them all as proper fractions. The power on top is smaller than the power on the bottom. Agreed? So right now it sounds really intimidating. All of this sounds really intimidating. All right? And notice that as I'm going, I am doing different letters because those letters mean different. Because if I use ax plus b and the ax plus b and ax plus b, that means I'm assuming all the a values are the same, all the b values are the same, and so on and so forth. But I can't assume that. Okay? So essentially what I'm doing here with partial fraction decomposition is that I'm taking a fraction and I'm breaking it apart to say if I was to sum up all these fractions, I would get the question. Is that fair? So I'm literally breaking apart a fraction that's already together and breaking them apart to be sums of parts. Okay? Then I'm going to solve for A, B, C, D, and more. You may need system of equations, and then rewrite the partial fraction. And then there's no examples. No, joking, joking, joking. Can you imagine? I'll go, okay, good luck. See you guys later. You're like, what the? All right, let's do an example here, and let's keep it simple. Okay? Let's say I have this. Oops, no, it wasn't x, it's 8. And let me go with x to the third plus 4x. What was one of the very first steps that we had? We got to figure out if it's proper or improper. What is it? Proper or improper? Proper. God, awesome. And if we know it's proper, what do we do first? Factor the bottom. Okay, can we factor the bottom? Yes. So this is going to be 8 over hello from the other side.
Over x times x squared plus 4.
All right. All right. So you know that these are product of two different things. Do we agree? Awesome. And nothing is repeated, right? Neither of them have powers. Is that true? Well, power of 1, sorry. Nothing is larger than the power of 1. So I'm going to write the first one as a over x. You guys see where the x came from? Then I'm going to add to that. The next bottom is x squared plus 4. Is that linear or quadratic? Hopefully quadratic, because x is squared, right? So that means my numerator must be a linear. So again, I need it to be a proper. So that means power on top has to be smaller. This power on the bottom is to the first power. That means the top has to be to the 0 power. This is a squared. That means it's a quadratic. So that means I need the top to be the first power. Hence, linear. All right, now we're seeing it? Questions? Are we okay? Do you see me pulling the denominator apart? Right, we're okay? Yes? Are we sure? Yes. Yes, that's why it's only a constant a. Because if I say ax is 0, it would just be a, right? That's the reason why it's just a constant a. Yep. So these uppercase letters, guys, just so you guys know, those are constants. Those are just constants. Those are just going to be numbers. Okay. So guess what I have right here? I have something called a
Equation?
what kind of equation? Rational equation. Very good. Yes, it's that equation with fractions in them. Hence a rational equation, right? We have a rational equation. All right, how do we solve rational equations? Guys, you guys had this in the intermediate. You guys had this in college algebra. How do we solve rational equations? Well, that's every equation we solve for x, but how do we go about solving a rational equation? we need to get common denominators. The sisters. Okay? So, what is the x missing?
X squared plus 4.
Okay. This is missing the x squared plus 4. If we do it at the bottom, we have to. And the x squared plus 4 is missing a. If we do it at the bottom, we have to do it to the top. And this denominator already has both of those things, right? So if we look, this denominator is the same as this denominator, which is the same as this denominator. True? Everybody agree? So that means I can rewrite this equation as 8 is equal to a times x squared plus 4 plus x times bx plus c. True? Not bad? So far? So would you agree with me that 8 is equal to ax squared plus 4 times a plus bx squared plus cx? Did I do my math right? I'm okay? Are you okay? So far, so good? Not too bad, right? Okay. So here's my question. What's A equal to? What's B equal to? What's C equal to? You're like, I don't know, dude. That's why you're teaching. Yes?
You could insert values for x.
How does that help me find A, B, and C?
Well, you could just set x equal to a number where one of the constant variables would equal 0.
Which is?
X equals to.
But then I would have to assume that the y value for that x value that you're about to put in is equal to 8. That would be me assuming, because if you pick an x to put in here, I have to assume the y value is 8. But I don't know if that's right. I don't know if 0, 8 is there, 1, 8, 2, 8, 3, 8. I don't know what it is. Does that make sense? What were you going to say? That won't work because they won't match up. I see what you're saying, because especially the first group, that's easy, right?
I was looking at the first group and then I looked at the second group.
That doesn't work. All right, so here's the thing, guys. This is actually, you're going to see this and you're like, oh, wow, I can't believe we just did that. So one of the things on the right side, one of the things you guys would do is combine like terms. Is that right? Okay, great. Let's go ahead and do that just for poops and laughs. We got ax squared plus bx squared plus cx plus 4a. Is that right? You guys, your mind's going to be blown right now. Your mind's going to be totally blown. You guys ready for this? You ready for this? Your mind's going to be so blown. Tell me when you were copying it, you were like, oh, crap. That was easy. Am I right?
Yeah.
All right. Look on the left side. What do we have? 8. Constant of 8. Is that right? Do I have an x squared term on the right? I mean, on the left. Do I have an x term on the left? We just have a constant of 8. So we want to look on the right side. Do I have a constant? 4a. Isn't 4a a constant? Didn't we just say that a, b, c is all constants? Right? So check this out, guys. You told me that the left side had no x squared term. That means I could write the left side as 0x squared plus 0x plus 8. Is that true? Are you seeing where I'm going with this? Is the left side true? That will still give me a result of 8. Is that right? Okay. That means the 0x squared is equal to ax squared plus bx squared. That 0x has to equal to cx. And that 8 has to equal to me my 4a. Because the x squared term has to match up. The x term has to match up. And my constant has to match up. True? Now, not just that. Let's even do this one better, because we could have taken out the x squared and it would have been a plus b times x squared. Is that right? So, over here, I can get an a value, can't I? That is going to be, a is going to equal to 2. So if I plug that back into the first equation, actually, let's name these. 1, 2, 3. So if I took this and plugged it into the first equation, I would have that 2 plus b has to equal to 0. True? So b must equal to -2. And what does this tell me about c? What's c equal to? Agreed? Is your mind blown? Does this make sense? Now I can rewrite the decomposition, meaning, oh boy. Chan, stop being lazy. Uh-oh. Does that make sense? Or should I do it this way? Here. Let me do it this way so that you guys aren't as confused. Okay? Would that help you make sense of it a little better? A little better? Are we okay? Not bad, right? Questions? You want to do another easy one, or do you want to do a hard one? Another easy one? Yes, sir? Oh, you want me to box it? Because I usually box things, right? So another easy one? Proper or improper? Awesome. So I got it. What's my first step? Back to the bottom. Go for it. Man, you guys already got the steps down. Love it. What is that going to equal to? Okay, so you had the factors being this way, which is A-okay, no big deal. And it doesn't really matter, guys, because when you rewrite it, it's going to come out that way anyways. And since there's no power greater than 1 on both of those, you just write those once. Okay? Awesome. Awesome. I guess I don't need to. So x plus 1 is missing what? X minus 2 is missing. Awesome. The numbers are the same. What's the 2 equation I can write from here? Five x is equal to what? So a plus b quantity times x. Is that right? And negative 1 is equal to? Awesome. So really, I could write this as that 5 is equal to a plus b, and negative 1 is equal to negative 2a plus b. Is there any way of solving this right now, just like this, like I did before? No. Right? But what do I have here? I got 2 equations, 2 unknowns. Right? So why not Multiply this by -1. Look at that! By golly gee, I just found A. What's B going to equal to? Not bad. Pretty cake. It's like it was so easy. Now you're ready for a hard one. Because the question should be, wait a minute, you mentioned about proper, but you also mentioned about improper. What the flip do we do with the improper? They don't even want to know. They're like, I'm out. You mentioned improper, I'm out. Okay, so let's look at improper. Improper. Yeah? Why that look? Does it not look improper? Because the power on the bottom is larger, right? You're like, is that why you were wondering? You're like, what do you mean that's improper? Right? The power on the bottom is larger. Oh, I'm sorry. Wait a minute. This is still proper. Sorry. Still proper. Still proper. Sorry. Thank you for that look. Still proper. However, do we know how to factor x to the thirds? How do we factor x to the thirds?
We could group to the terms.
How?
You could say x cubed minus 7x squared in parentheses, and then factor that.
The problem is that the other one doesn't calculate it out. So, because what he was thinking about was doing factor by grouping, but that won't work, right? Now, if you remember, when we did polynomial functions, we can find the roots, right? The possible zeros. Remember? We had to take, please, no, not that one. So let's type this into Desmos, just so you guys know what I'm talking about. So in Desmos, if I type in x to the third minus 7x squared plus 15x minus 9. Did I type that in correct? X to the third minus 7x. Blah, blah, blah. Okay. What do we know about those two roots? I want to be even nicer to you guys.
One has a multiplicity of 1, and the 3 has a multiplicity of 2.
Oh. Do you remember that? Because it bounces off is a multiplicity of even. Because it goes through as an odd multiplicity. It has to be 2 and 1 because the power is to the third power, right? It can't be 4 and 3 because it's not power 7, okay? All right, so let's talk about this. Let's talk about what's the appropriate way of doing it versus inappropriate way of doing it, okay? This, do on an exam, don't really care. We're going to go back exactly how we did polynomial functions, which was grab 1, right? We're going to grab 1. We're going to grab the 1, right? Which means one of my factors is going to be x minus 1. So I'm going to go ahead and take the x minus 1 from Desmos and do a long division with the this. So if I do long division, are we okay? So this is telling me that this right here is equal to which I can factor that, right? Are we okay there? Oh, yep. Actually, before I do that, let's do this. Now I do that. So this is a repeated linear. Since it's the second power, I have to write one for the first power and one for the second power. That's why you see there's 3 fractions here. Okay? Go ahead. So this right here, let me do it up here so that people at home. This right here is considered a repeated linear, which means that I have to write one for the first power and another one for the second power. Yep. So if it, let's say, was the third power, then I got to write another one to the third power as well. So always write from the first power to the second power all the way to whatever that power is given as. Okay? But if it's only to the first power, it's just 1. So essentially, whatever the power is how many more terms you have to write. If it's to the third power, that means you got to write 3 terms, but 1 is to the first, 1 is to the second, 1 is to the third. Okay? It can. Depending on how much of an a-hole Chan is. We all know. We all know. Chan can be one. So from here, we need common denominators. Oh boy, I need more space than that. This one's missing what? We do it to the bottom, we got to do it to the top. This is the one I need more space on. The numbers all the same? Not too bad? Ooh, how do I want to do this? Ooh, I like that idea. Let's do that. Y'all see what I did here? That makes more sense, right? I don't know why that just popped in my head and why I didn't do that in the notes. Instead of writing this big old long line and then trying to break everything down. So here I can see, oh, I have 2 is equal to A plus B. I have negative 11 is equal to negative 6A minus 4B plus C. And I have 17 is equal to 9A plus 3B minus C. Nothing I can solve for, yeah? But I do have 3 equations, 3 unknowns. Everybody see what I did there? I added equation 2 and 3 together because since the C is, right? And I got to get rid of C because this equation doesn't have C. So I want to get rid of C. Make sense? So I only have A and B left, so I have 2 equations, 2 unknowns. Then I can add those 2 together. Wow, this made it easy. What's C equal to? Thank you. Does that make sense? We're okay there? Are we sure? Yes? Sorry. Questions? Does it really help? Huh? Yeah. But does doing it first help you? Okay. Because that's what I'm noticing. That's what you're doing. So you're like, ah, got it. Yes? Correct. Well, system equation is, I'm doing system equation only because none of these 3 equations can get me A, B, nor C. Right? So like the first example, it was easy to get A and B, or get one of those variables. Then I would stay with that method. But once I write the equations out and I can't get any of those letters, then I would jump into systems. And you're right. The reason why I added the last 2 or try to use the last 2 is because one of them already has C gone. So I want to get rid of C so that I only have A and B left. makes it easier. Okay? Because notice when we did 3 equations, 2 unknowns, we always did, pick 2 pairs of the equation and eliminate the same variable out so that we have 2 equations, 2 unknowns. So same exact idea. Are we okay, guys? Not too shabby? Awesome. Oh boy. Now we get to a whole new territory. Now to chapter 13. This is nerve-wracking. Okay. So a sequence is just a function whose domain is a set of positive integers. It's going to be just a series of points. Okay? So you usually see a sub n. So when you see this squiggly bracket with a sub n, you know it's going to be a sequence. And then what it would do is it would tell you what the formula is, per se. Okay? So if it was to ask you for your first term, that means we're looking for a sub 1. Which means that your n is also 1. So this is going to be 1 minus 1 divided by 1, which is 0. Okay, so based on the formula that's given on that example, that means the first term is going to be 0. If I was looking for the second term, that means n is going to be 2. So it would be 2 minus 1 over 2, which is 1/2. If I was looking for the sixth term, that means my n would be 6, which would be 6 minus 1 divided by 6. And if I was looking for the nth term, then n would be n, which is n minus 1 over n. This right here, guys, is known as your general term, meaning the general term is already given to you. Not too shabby? Seems like I'm going in circles here. Oh, no, there is another section that literally feels like going in circles. So, not bad? All right, so let's say they give you this right here. So I see this, squiggly bracket, b sub n. Tells me it's a sequence. What is that general term? The general term says -1 raised to the n power times 2 times n. Great. So let's go ahead and find the first 4 terms. Okay? So if I'm looking for the first 4 terms, the first term is going to be b sub 1. The second term would be b sub 2. The third term would be b sub 3. The fourth term would be b sub 4. And you're like, okay, when is this going to get hard? So we just apply, n is going to be 1, n is going to be 2, n is going to be 3, n is going to be 4. Not that hard, right? So what do we get when we do n is, what is the first term going to be? Please don't break your brain. Negative 1 to the first power times 2 is negative 1 squared times 4 is negative 1 to the third times 6 is negative 1 to the fourth times 8 is. So what do you notice about the sign as we go from one term to the other?
It changes between positive and negative.
In other words, they're alternating, right?
Yes.
So we call this a alternating sequence. So, yes, it's very easy for them to give us a general term and for us to find each different terms. The question is, if they were to give you the sequence, can you give the general term? So here's 3 of them. 1, 3, 9, 27. Can we figure out what the general term is? Now, mind you, this right here will be your first term. This right here will be your second term. This right here will be your third term. And this right here will be your fourth term. So whatever you pick as your quote-unquote general term has to work. So what do you think the first one is going to be? What do you say? Well, no, what is the general term? That means there's not going to be any equal sign there because the equal sign is already taken care of. So if you want to say n to the third power, that's okay. But would that work? So if I said n to the third power, when n equals 1, does that work? Right? 1 to the third, because this is n equals 2, so it would be 2 to the third. That would be 8, right? So that doesn't work. Okay.
Is it 3 to the n?
Let's try 3 to the n. So when n is equal to 1, uh-oh. Because if n is equal to 1, right? If we put 1 in here, that'd be 3. So this should be a 3. You're very close.
What if we put in 0?
But why would we put in 0? Because this has to be n equals 1. Huh? That won't work either. Huh? 1/3 to the n wouldn't work either. Because 1/3 to the first power is just 1/3. You're so close.
3 to the power of 1/3.
Whoa. That makes it even more difficult. Because when n is equal to 1, it'd be 3 to the 1/3.
N to the 1/3.
Oh, no, wait, is this just
So what's,
n cubed?
huh?
Wait. N cubed. No, wait, no, wait.
You're so close. Because you wanted it to be 3 to the 0. Yes.
3 to the 1 is 3, and then 3 squared is 9, and then 3 cubed is 27.
Okay. So, great. Great, 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 great. So let's look at this.
That's the pattern. I just don't know how to write it.
Okay, so look. 3 to the 0 is this. 3 to the 1 is this. 3 squared is this. 3 to the third is this. This is n equals 3, n equals 4, right? Okay? So look at the difference between n and the power you wanted.
3 to the n minus 1.
Bingo.
That's it.
See what I'm saying? Right? She knows what she wanted, but she just didn't know how to put the general term together. But if she would just lay it out, she would see, oh, look, if I just took the n and took away 1, I would get those powers that I wanted. Okay, how about the second one? What makes 2, 4, 8, 16? I'm going to guess the next one is 1 over 32nd, and then 1 over 64th.
1 over 2n.
2 to the n. I know. That's why I wrote it this way. How about the last one? How do I get 3, 5, 7, 9?
2 plus 1.
Cheater. Right? And try these, guys, because this is n equals 1, n equals 2, n equals 3, n equals 4. See if that works. See what I'm saying, guys? Any questions on that? It might take some work, huh? How many of you guys learned factorials before? Okay. Go ahead.
How I remember factorials is it's just a number times every other number for it until it reaches 1.
Before it until it reaches 1, yes. It's a product of itself times every integer or every whole number down to 1. Except there are two key ones that I can't really explain, at least not 0 factorial. But 0 factorial and 1 factorial are both equal to 1. Why? I don't know. Can't explain it. So 5 factorial, which just means 5 times 4 times 3 times 2 times 1, which is equal to 120. Now, 6 factorial, you could say that is equal to 6 times 5 times 4 times 3 times 2 times 1. But since I already did 5 factorial, I can just say that this is 6 times 5 factorial. Oh, forgot the... Does that make sense? That's the reason why they have this equation here. N factorial is just n times n minus 1 factorial. Because that's what this is saying, right? 6 factorial is 6 times n minus 1, so 5 factorial. Are we okay so far? So recursive formula. All recursive formula is saying is, what it means is that the next term depends on its previous term. So without its previous term, you can't get to the next term. So I can't get to the 4th term unless I have the 3rd term. I can't get to the 3rd term unless I have the 2nd term. I can't get to the 2nd term unless I have the 1st term. meaning that it has to give you two things. It has to give you what the value of the first term is and what the rule is for the next term, right? So here's the first term, and this is the rule. So that means S sub 2 will equal to this 4 plus the previous term. So S sub 1, oops. Which I know S sub 1 is 2, so I know that this value is going to be 6. And to find S sub 3 is 4 plus my previous term, which is S sub 2. Well, I know S sub 2 is 6. So that means S sub 3 is going to be 10. And to find S sub 4 is 4 plus the previous term, which is the third term. And the third term was 10. So that's why I know that the fourth term is going to be 14. And I want to remind you guys that I've given you guys templates for these things here, okay? So that you can fill in. I'm going to go ahead and skip this one here because it's the same exact idea. It just takes the previous term into play. But I want to talk about summation. So if I want to sum a sequence, I can write it simply with a summation. The bottom is always where does it start. And it's going to tell you what letter to replace that number. And the top number is where does it end? Where does it stop? And then after the summation is what is the rule. So K always increases by increment of 1. So this would be 1, then 2, then 3, then 4, then 5. So that's the reason why this would be, the first term would be A sub 1 plus, because of summation, A sub 2 plus A sub 3 plus A sub 4 plus A sub 5 all the way to A sub n. Okay? Does that make sense? So, in other words, if I was to look at this right here, if it was the summation of 2k, when k is equal to 1 all the way to 5, it means that, and the rule is 2 times k. Well, k starts at 1, so the first term is going to be 2 times 1 plus 2 times 2. Next term will be 3. Next k would be 4. Next k would be 5. And since that's when it tells me to stop, I stop at 5. Then I had to sum all of those together. Log sub e something. So that's going to equal what, 30? How many of you guys are multiplying them all together and then adding them? Guys, look at this. Isn't there a GCF of 2 in all of this? Yes? So let's take out the GCF of 2. So all I got to add is 1 plus 2 plus 3 plus 4 plus 5. And then multiply by 2. 1 plus 5 is 6. 2 plus 4 is 6. That's 12. Plus 3 is 15. Times 2 is 30. Dang it. Here are some properties of summation. Just like, good thing there's only 2 minutes left. Well, there's the reason why, if you look on the Canvas homepage, I gave you guys blanks on purpose. Okay? So, So this rule right here is exactly what I was just explaining to you. Because it was 2 times k, right? I said there's a GCF of 2. Well, that's what this is really doing, just taking the 2 out and then adding the k's together. So the 1 plus 2 plus 3 plus 4 plus 5, sum those up and then multiply by the 2. That's all this is saying. These two are, I think, should be pretty obvious. All this is saying is I can add these two together and then sum them, or I can sum them individually and then add them together. Subtracting, same thing. So the first 3 isn't that big of a deal. The last 5 is a huge deal. Here's the good news, though. It's on your cheat sheet. But you have to understand it. And since it's time, I will explain to you guys how to use this in the next class. Okay? So, just so you guys understand something, though. The first one, because remember when I said k starts equal to 1, right? To a number. This rule right here is saying, what if k didn't start at 1? That's what that top rule is talking about. I'll explain how to use it. The last 4 rules is talking about if we were to do a summation, here is the general summation at the end. What is it actually equal to at the end? This way you don't have to actually apply the rule so many times and trying to find the summation of that whole thing, of that whole sequence. This is the end result or the summation of that sequence. Okay? I'll explain that in the next class. So ladies and gentlemen, please have a wonderful, blessed day. Please be safe. Love you guys. See you guys on Thursday. Peace.